अस्सलाम वालेकुम। तो once again start करते हैं. The function is differentiable or not at a single point. To be differentiable, to have a derivative, a function must be continuous and smooth. The derivatives will fail to exist at corners, cusp, vertical tangents, and discontinuity. So all of these points we will see in coming slides as an example. So most of the functions we study in calculus will be differentiable, except those points we have just seen. So a function is differentiable at a point, is continuous at that point or not. We have a theorem here that if f is a derivative at x equals to a, this is a point where the function is differentiable. If a derivative, then the function or f is continuous at that point, x equals to a. Since a function must be continuous to have a derivative, if it has a derivative, then it is continuous. That is so simple. So the proof of this point is that we have a function f prime of x equals to the limit s tends to 0 f of x f of a plus h minus f of a all over h. Since a function is differentiable at a point a, this is the condition. So the differentiability or the derivative exists, the limit exists. Then the f is continuous at point a. So it must be the limit where x approaching to a, f of x equals to f prime of x, f prime of a. So it is the original definition of continuity at a, if we recall. So we have the function limit when x is approaching to a equals to f of x minus f of a equals to 0. So we can rewrite it by x replacing with a plus h. So we have now the f of x with f of a plus h minus the original function f of a equals to 0. So the actual argument and replacing h with 0, we will have a function with where limit h tends to be 0, f of a plus h minus f of a. So if h is 0, then f of a minus f of a will be cancelled out, and we thus have a 0 function here. So by looking at these figures, we have a point and this function. If the function is not continuous at this point a, it is discontinuous at this point a, then the function or f is not differentiable at this point because the function has breaks at this point. This is the original function y equals to f of x, and we have a break at this point, particular point or a specific point a. And we have another function having some breaks in this function. So the function is y equals to g of x, and having the breaks at minus 2 and 2 here. So this function is also not differentiable at these points. So the vertical tangent line, we have f prime of 0 with the not existence, because at this point 0 the function is not differentiable. So from the limit extends to 0 subscript or superscript plus indicates that the function is from right hand side or the positive side. So on every point we have a positive infinity, and on the left hand side where x approaches to 0 from minus or left hand side, f prime of x is always minus infinity. So here also the limit does not exist at 0. On vertical tangent lines are at this point 0. The limit or differentiation does not exist. Same like this function as at this point -2, where g prime of -2 is undefined here also, and g prime of 0 is undefined here. G prime of 2 is undefined also here. So, for example, we have a function f of x equals to absolute value of a. Is this function is differentiable or not? Because we have a function absolute value of x. So if x is greater than 0, then absolute value of x is always positive x. We don't have need to write here plus sign, because we assume that this is a positive number, and we can choose h small enough that x plus h is greater than 0, and hence the absolute value of x plus h equals to x plus h, and therefore for every x greater than 0 we have the f prime of x equals to the limit where h tends to 0. We can write in the basic uh, derivative formula x plus absolute value of x plus h minus absolute value of h all over h, absolute value of x all over h. Thus we can write here the limit where h tends to 0, x plus h minus x all over h equals to limit h tends to 0, h over h, because this positive x and negative x just to be cancelled, and we will end up with h over h, which results in positive 1. And so f is differentiable for any x greater than 0. Similarly, for x is less than 0, we have the absolute value of x equals to negative x, and h can be chosen small enough, arbitrarily close to that x plus h is less than 0, and so absolute value of x plus h equals to minus x plus h. Therefore, for every number x less than 0, and we have the by definition f prime of x equals to limit h tends to be 0, absolute value of x plus h minus absolute value of x all over h. We put the values less than 0. We have the limit h tends to be 0 minus x plus h minus x all over the h. So this minus into minus will be plus, and this is a minus. So minus uh, x and plus x will be cancelled out, and minus into plus will be minus. So minus h all over h will remain. So we have limit h approaching to 0 minus h all over h. Minus h over h. So we will end up with minus 1. So this fails to exist two-sided limits, and so f is differentiable for any x is less than 0, but not 8 f of 0. Okay, that is the reason the limit does not exist, or the derivation or the differentiation does not exist at f of 0. So for every x equals to 0, we have to investigate f of 0 equals to limit h tends to 0, f of 0 plus h minus f of 0 over h. So equals to limit h tends to 0, absolute value of 0 plus h minus absolute value of 0 all over h. If it exists, let's compute the left and right hand limits separately. So the limit h approaches to 0 from the right hand side, this plus sign indicates that absolute value of 0 plus h minus absolute value of 0 all over h equals to limit h approaches to 0 from the right hand side. Absolute value of h, 0 plus h will become h, and minus 0 does not affect the h, so h upon h we have h upon h equals to 1. And what about the left hand side? So the limit h approaching to 0 from the left hand side, we have 0 plus h minus 0 all over h. We have now the absolute value of h upon h. So we have limit h tends to 0 from the left hand side minus h over h. We will end up with minus 1. So since these limits are different and f of 0 does not exist, thus f is differentiable at all x except 0. So a formula for f prime is given by f prime of x equals to always x is greater than 0, we have 1, and always x is less than 0, we have minus 1. So this figure we have seen before that there is a discontinuity. Okay, we have all x values greater than 0, we end up with 1, and we have all the left hand side values are x is less than 0, we end up with minus 1. How? This is too much pretty simple. So differentiability, I am having the intermediate value theorem for derivatives. What it says? It says if a and b are 2 points in an interval on which f is differentiable, then f prime takes on every value between f prime of the point a and f prime of the point b. ओके, तो ये क्या कहता है, हम इस पिक्चर में देखते हैं. हमारे पास एक पिक्चर है और इस पिक्चर में दो पॉइंट्स हैं. एक पॉइंट है ए where we have a differentiation at f of f prime of a equals to 1 over 2, and दूसरी पॉइंट है हमारे पास b, f prime of b equals to 3. In between these 2 points, every point is differentiable. Okay, between a and b, the f prime must take on every value between 1 upon 2 and 3. तो 1 upon 2 और 3 के दरमियान जितने भी वैल्यूज हैं वो सारे के सारे डिफरेंशिएबल हैं, हम उनको डिफरेंशिएट कर सकते हैं. तो कुछ एग्जांपल्स. कंप्यूटिंग डेरिवेटिव्स इज नॉट अ पिकनिक. सो कुछ लॉज हम पढ़ेंगे, कुछ रूल्स हम पढ़ेंगे जो इस कंप्यूटेशन को बहुत ही इजी बनाएंगे, और इन लॉज और रूल्स की मदद से हम डेरिवेटिव्स बहुत ही आसानी के साथ मालूम कर पाएंगे. So the problem 1, find the equation of a tangent to the y equals to f of x equals to x cube minus 2x at the point where x is under root 2. So the solution to the problem is that what is the value of under root 2? Okay, you can guess, but it's 0. Here, an approximate graph of this function is that where we have x cube minus 2x, we have the value of under root 2 is 0. Okay, to get the slope of the tangent, we must find, first of all, the limit. So the limit and the derivation function, the differentiation limit is, or the definition is, limit where h tends to 0, f of x plus h minus f of x all over h. This is the formula we will be using again and again. So you are supposed to have a good grasp of this फार्मूला. ये फार्मूला अच्छी तरह से याद कीजिएगा, बार बार इसको इस्तेमाल करेंगे, बार बार इसकी ज़रूरत पड़ेगी. That is the limit where h tends to 0. What we do, we just see that this formula f of x plus h, जहाँ पर भी हम x देखेंगे उसको रिप्लेस कर देंगे x plus h के साथ. तो x plus h cubed minus 2x is a 2x plus h minus the original formula x cube minus 2x all over h. तो इसको सिंप्लीफाई करेंगे. फर्स्ट ऑफ ऑल, दिस इज अ x plus h with power 3. We simplify this as a x cubed minus x cubed, sorry, plus 3x square h plus 3x h square plus h cubed minus this by of the formula 2, and 2 will be multiplied by 2 times x is 2x minus into plus, it will be minus 2h, and minus by the original definition or original formula, we cannot omit it. So minus x cubed minus into plus, it will be plus, minus into minus, it will be plus. So 2x. We will see that what are the common values or common factors will be cancelled out. We have x cube of plus here and x cube of minus. Those are cancelled out. 2x of minus and 2x of plus will be cancelled out. Okay, so what will be end up? We will end up with the limit h tends to 0, where 3x square h plus 3h square plus 3 plus h cube minus 2h all over h. We will have common 1 over h, so h will be cancelled out, and we will end up with 3x square plus 3xh, because h is square here, so 1h is cancelled here, and 3xh plus h square, h cube will become h square minus 2. So we have, by putting the value of h as 0, or we have equals to 3x square minus 2 all over become 4. How? Because we have a formula now that 3x square minus 2 all over is equal to 4. So the slope of the tangent is 4, and we can find its equation. We have a slope and we have the equation now. Since we know that it goes through the under root 2 and 0, we get y equals to 4x minus under root 2. Okay. So second example, find the derivative of the function f of x equals to x square minus 8x plus 9 at the number x, where we assume that the x is equals to 0, equals to a, sorry. So a prime of a equals to limit h tends to 0, where we have the formula f of a plus h minus f of a all over h. So we will put the values that this is the x square, so it will become a plus h square minus 8. X will be replaced with a plus h plus 9, and this minus sign is by the original formula. So we will have the original function here, f of x, x square will become a square minus 8x will become the 8a plus 9. Okay, it's so simple. So first of all, the limit where h tends to 0, we have a square plus 2ah plus h square. Pretty much simple. Minus the minus sign here, minus 8a, because 8 times a will be 8a, minus into plus will be minus, and will be 8 times h will be 8h plus 9. Now this is the original symbol by the original formula, that is a minus will remain same, and the a square minus into minus will become plus, 8a minus into plus will be minus 9. Simple. So we have a square of plus and a square of minus will be cancelled out, and we have 8a of minus and 8a of plus will be cancelled out, plus 9 minus 9 will be cancelled out. Okay, so we will end up with h as limit h approaches to 0, 2ah plus h square minus 8h all over h. So if we get common 1 over h, or this h divided by this h and h square and h, we will end up with limit where h tends to 0, 2a plus h minus 8. And if we put the h's limit to 0, we will end up with 2a minus 8. So now find an equation of the tangent line to the parabola. What is the equation? X squared minus 8x plus 9 at the point 3 and minus 6. We have 2 points now. So the derivative of the function is, which is the function? F of x equals to x squared minus 8x plus 9 at number x equals to a, and we have a formula of f prime of a equals to 2a minus 8, as we have just seen that 2a minus 8. This is the formula. So we have 2 points now, therefore the slope of tangent lines is 3 minus 6 is where x and y values. X value is 3, so f of a means x value, or a value of a is 3. So we have 2a, as we have here 2a minus 8. So 2a means 2 times 3 minus 8. It will become minus 2. Now we have a point minus 2 for the slope of the tangent line. So thus an equation of the tangent line, what it says, that y minus 6 equals to minus 2x minus 3, or in other words, we have y equals to minus 2x. We have the original function here, parabola, where we have y equals to x square minus 8x plus 9, and we have 2 points, 3 of x-axis and minus 6 of y-axis. So we'll end up with minus 2x here, and this is the slope of the tangent line. So some more examples of derivatives. We can compute these functions by using the definition of the derivatives. The definition implies that f prime of x equals to limit h tends to 0, f of x plus h minus f of x all over h. These are the functions. The first function is f of x equals to 2x minus 1. So simple. Second function, f of x equals to x square. Third function, f of x equals to 2 plus h, or 2 plus x. Fourth function is f of x plus equals to 1 over x. Fifth function is f of x equals to x cubed and x square. So let's examine one by one. So we have the first function, f of x equals to 2x minus 1. Just simply by replacing these x's by the definition. We have the original definition, f prime of x equals to limit h approaches to 0, 2x minus 1. So we have here, we can see that f of x plus h. So where we see x, we replace it by x plus h. We have 2x plus h minus 1 by this formula, and minus sign by the original formula will be preserved. So the original formula is f of x 2x minus 1 all over h. So by simplifying this, we will get that 2x plus 2h minus 1 minus 2x minus 1. So here we can see that this minus into minus will become plus sign here. So we have limit where h tends to 0, 2x plus 2h minus 1 minus 2x, minus into minus will become plus 1 all over h. We will get that 2x of plus and 2x of minus will be cancelled out, minus 1 plus 1 cancelled out, and we will remain that end up with 2h all over h here. By putting the value of 0, this will become all over odd, but by cancelling h in the numerator and h in the denominator, we will be end up with 2 only. So the derivative of this function f of x equals to 2x minus 1 will be 2. Okay, the second function f of x equals to x square. When we see that, or when we will have a function, जब भी हमारे पास कोई फंक्शन या कोई भी प्रॉब्लम आएगा तो हम क्या करेंगे, सबसे पहले थोड़ा सा स्टॉप करके उसको देखेंगे कि क्या ये फंक्शन फैक्टराइज हो सकता है, क्या डिफरेंशिएशन डायरेक्ट अप्लाई करनी है, या क्या इसमें कुछ अलजबरा हम इस्तेमाल कर सकते हैं। तो इसमें हम देखें कि एफ ऑफ एक्स इक्वल्स टू एक्स स्क्वायर है, तो एक्स स्क्वायर जब आता है तो एक्स की जगह पे हम एक्स प्लस एच रिप्लेस करेंगे, रखेंगे, और दिस होल एक्सप्रेशन विल बी स्क्वायर्ड। जब स्क्वायर्ड होगा तो इसको हम फैक्टर कर सकते हैं एक्स प्लस एच, एक्स प्लस एच। ओके, फर्दर सिंप्लीफाई करेंगे तो हमारे पास एक एक्सप्रेशन ये आएगा कि एक्स इंटू एक्स विल बी एक्स स्क्वायर 2xh प्लस एच स्क्वायर। अगर आप इसको x प्लस एच ना भी लिखें तो आप इसको डायरेक्टली कर सकते हैं कि एक्स स्क्वायर प्लस 2xh प्लस एच स्क्वायर। ओके, ये फर्दर जो अल्जेब्रिक एक्सप्रेशंस हैं इसको मैंने इसलिए लिखा है कि आपको ज़्यादा समझ में आ जाए। इसमें कोई क्वेश्चन वगैरह हो तो हम बाद में डिस्कस करेंगे। तो इक्वल्स टू लिमिट वेयर h tends to 0, we have x square plus 2xh plus h square minus the original function x square all over h. So we will end up with by cancelling plus 2x plus x square and minus x square, we will have now the limit where h tends to 0 to xh plus h square, and we will have a common from h to xh and h square here. So by getting the common, where limit h tends to 0, h times 2x plus h and h. These both h's and numerator and denominator will be cancelled out. And then we will end up with where limit h tends to 0, 2x plus h. And if we put the value of h as 0, so we will have the limit h approaches to 0, 2x plus 0, and the derivative of this function x square is 2x. So the third function f of x equals to 2 plus x. It's very much simple. By the help of original definition is limit h tends to 0, 2x plus h, 2 plus x is replaced with 2 plus x plus h minus the original function 2 plus x all over h, and the limit where h approaches to 0, 2 plus x plus h minus 2 plus x all over h. So we have the limit 2 plus x plus h minus 2 minus into plus become minus x all over h. So by cancelling out the common terms, plus 2 minus 2 will be cancelled out, and minus x and plus x will be cancelled out. We will be end up with h over h, which is 1. Fourth example is that 1 upon x. So by the definition, we have the limit where h approaches to 0, that is 1 upon x, and 1 upon x will be replaced with 1 upon x plus h minus the original function 1 upon x all over h. So further, the limit h approaches to 0, 1 upon x plus h minus 1 upon x all over h, where the limit is h is approaching to 0, x minus, if we further solve it, we have x minus x plus h all over x times x plus h upon h upon 1. Okay. Equals to limit where h is approaching to 0 minus x minus h all over hx times x plus h equals to limit h approaching to 0. It will be, it is a minus h, so clearly it is a minus 1, and h will be cancelled out, so we will end up with x times x plus h. Hence we will have that this h has a value 0. So minus 1 x times x plus 0, we will end up with minus 1 x times x is x square. So the example, f of x equals to x cubed and minus x square. सो फर्स्ट ऑफ ऑल हम इसको देखेंगे कि हम इसको फैक्टराइज कर सकते हैं या फर्दर मजीद इसको लिख सकते हैं, या इसको डायरेक्ट डेरिवेशन के लिए सिर्फ लिमिट की वैल्यू अप्लाई करें और हमें डिफरेंशिएशन मिल जाए, या फंक्शन जो है वो डिफरेंशिएबल हो। तो हम देखेंगे ये एक क्यूब्ड फंक्शन है, दूसरा स्क्वायर है। इसको फर्दर सॉल्व करते हैं तो रिप्लेस करते हैं एक्स प्लस एच क्यूब्ड माइनस एक्स प्लस एच स्क्वायर। ओके, तो हमारे पास क्या आएगा, एक्स क्यूब्ड प्लस 3x स्क्वायर h प्लस 3x h स्क्वायर प्लस h cubed minus by this formula. So minus sign will be remain the same. This will be x square plus 2xh plus h square. हम इसको फैक्टराइज कर सकते हैं, यस कर सकते हैं। तो अब हम इसको रिप्लेस करेंगे ओरिजिनल डेफिनेशन। The definition says that the limit where h approaches to 0, we have x plus h cubed minus x plus h square minus x cubed minus x square all over h. So अगर थोड़ी सी अलजेब्रा हम यहाँ पे इस्तेमाल करेंगे तो हमें क्या मिलेगा, लिमिट वेयर h is approaching to 0, x square h plus 3x h square plus h cubed minus 2x h plus h square, and we have the limit h approaching to 0. We have a common h here, so this will become 3x square plus 3xh plus h square minus 2x plus h. By further simplifying, these both h's will be cancelled out. We will be end up with 3x square plus 3xh plus h square minus 2x plus h, and equals to 3x square plus 3x. By putting the value h as 0, we will be end up with 3x times 0, 0 square minus 2x plus 0, and thus we will have 3x square minus 2x. That is the differentiation or derived of a function of this original function f of x equals to x cubed minus x square. That's all.